Welcome to today's webinar. The topic today is advantages and functionality of building model add-on in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and PR in the company Dlubal Software. For instance, the German and English webinars, newsletters, technical content of the website, and so on. I will be the moderator today, and I will answer your questions during the webinar. My colleague Richard Hase will be the presenter today. He works in our company in the customer support team and also in the development teams of the add-ons concrete design, building model, and the program R section. Okay, then I say some words how you can ask questions. At first, I switch off my camera that you can see the full screen. You can press that button with the question mark, then enter your question here, press send, and I will receive your questions and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's at the moment all from my side. I hand over to Richard. Richard, it's your turn.
Yes, thanks, Andreas, for your introduction. And hello and welcome from my side to the today webinar. Then let's start with the content from today. In the first step, I will show you a quick modeling method with the building model add-on. There is option which is exclusive in the building model add-on, where you can design very fast your building. Okay. Then to the next chapter, the story types. These story definition types are the main content, I would say, in the building model add-on, and I will tell you the difference between this story types and show you on the model a comparison between the results and Okay, then we have two additional objects added in the building model add-on. That's on the one side shear walls and on the other side deep beams, and these two objects you can define on manual way and you can design this types, and these types also give you the opportunity to get informations about the stories and the forces which are there. Okay, and at the end, I will tell you about the result evaluation, which results you all time get independent of the story types in the building model add-on, and show you what you get for informations with the results. Okay, then to our first capital, the quick modeling here with a background layer for easier way. I will import an DXF file, and it's a modeling option from bird's view, floor plan, top view, however you want to call it. And at the time we can we have added this button in the building model add-on. It's exclusive button, and you can see the objects you can generate or modeling in this bird's eye view. And so then let's switch to RFEM 6, then I can show you what I mean. yeah, I start a new model. Let's call a building model. And at first we must activate the add-ons, of course, the building model, and today also the concrete design, that I can show you um, the configurations and special options which are connected with the building model add-on, when the concrete add-on is activated. And to the quick modeling, I also want to show you our load wizards. Yeah, and for this today we want choose the German annex. And okay, so when you activate the building model, automatically here under setting and options, our surface cells are activated, and this is a nice feature for surfaces which are, let's say, separated by lines or different parts, and you can control and modify the surface cells. But yeah, I will show you. So okay, then let's start with the new model. Okay, then let's delete all objects that we really have a new model. Let's start with the materials. There I need as concrete at first. Let's take C2530. Then we need reinforced steel. Let's take the B500. Okay, and also we need masonry. There, let's take okay, this one. Okay, then we have defined our materials. Yeah, and okay, then I will upload my DXF file, my background layer, that I can show you what this building is about or how it looks like. Okay, and now we see it's nothing big. It's a simple model, but yeah, for this case it's good. Then let's change to meter. And when you add some background layers, you have here two selecting points. The first, you can choose, I will set it here to the 0 points, and the second you can choose in your DXF file. I added here some statical system lines. I will choose this line for this. Okay. Sorry. And yeah, now we have our DXF background layer, and the walls on the outside should be in masonry, and the inner side walls I will create in concrete. Also, this slab cantilever, so not really cantilever, but it's only in the ground floor. And here we have some columns. And yeah, so then let's go back to our definitions at the begin. So materials we have defined. Now let's define our section. For the column, it's concrete. And now I will show you also a nice feature. When you work with your DXF file, you have the option to measure the um, properties of the section. So let's take this. Okay, 25 centimeter, and also in the other side, also 25. Okay, then let's say okay. And now we need some thicknesses. So maybe let's start with the masonry walls. Okay, and also we have here the same type. Okay, then let's choose this 24 at for the walls on the inner side with the concrete material, and we can do here best way 24. And yeah, for the foundation plate, let's say we want to have a thickness of 35 centimeter. Okay, then let's say okay. So we have defined the materials, the section, the thickness, and now let's go here. And okay, then we must spring to the building model add-on, and we will define now our building stories. Oh, wait, I want to okay, a new one with a height of 3 meter. And now again 4. And yeah, you also can modeling at first, but because of this fast modeling, you need to define the stories at first. And you can switch here, and now you see story heights here. And yeah, here are the floor modeling options, but I will show you at a later point. So now we have our materials, our sections and thicknesses, and define our stories. And now we can start to define with the fast modeling. So let's start with the walls. Let's take here our masonry material, and now we can. Oh, yeah, right. For this, you need to define the stories. So you can choose, okay, if you want this walls in this example uh, only on one floor or on different floors, or in our case, we want to have these walls in all stories, then apply, and let's start. Okay. Okay. So now you see here this this mass, and it's also because of the building model add-on. Um, the add-on now create a center of mass, and now all these masonry walls are edited with their mass, and for each story. So you see now all walls, outside walls are created, but let's continue with the inside walls. 24, yeah. Okay. Okay, here and here. Here and here. And the last one is here. Okay, let's check if I get all walls. Yeah, it looks good. Okay, then we want to define our columns with our section we have defined before. And now we don't want it in all stories, only in the ground floor. Say apply and click here and click there. Okay, then same procedure for the floors. So 24, okay. And for all stories, apply. Oh, a moment, that's wrong. Okay, again, floor for all and apply. And yeah, okay. Now we have also floors. Now we need this, I say, cantilever floor. Okay, also 25 and only in the ground floor. Let's start at this point. Okay. And here we have an opening in the walls for stairs. And let's define this floor opening. Here, let's see, not in the last floor. And okay. Okay. So now we have our openings, and you see you have in a short time generate a building. The only thing you must generate on manual way are the openings, the windows and the doors, for example, or other openings in the building. And to don't waste time, I have modeled this here. Maybe I can switch back to the full model, and there you see the openings. And I added also some load transfer surfaces, because imagine when you define wind loads and you define it only on the masonry surfaces, these areas for a closed model are missing at the end, so you can define this load transfer surfaces, and this surfaces only loads the transfer only the loads to the sides, and don't have a stiffness effect or such thing, only for load transfer. Okay, then another nice feature which the building model make automatically is in the navigator views. There is a point building story, and when you activate it, activate this, you can or you see every story you define. There's automatically um, created a view, so you can fast um, spring between the stories for loads and such things, and I find it's very nice feature. Okay, then what I want to show you also, yeah, for example here, you see it's one big wall, and you see this blue crosses. Oh wait, maybe we change the view. Oh, it's not function how I wanted. Yeah, you have only one big surface, and with this surface cells, you have the option to when you click on the surface cell, to give these cells other thicknesses, and um, all, yeah, then with the different thicknesses, you can also design the surface as one surface, so it's nearly the same um, effect like when you um, wait the no, the surface sets, but so it's a more easier way and faster way to define this here. Okay, then I want to show you in the concrete design, when you activate the building model add-on and also the concrete design, you find in the configurations some additional points, which is only possible with this model add-ons. And yeah, here some options for the deep beams and for the shear walls. So yeah, that's now possible. Okay. Yeah, then what I also called, I'll tell you before, maybe we switch to the loads. Yeah, sorry. Here we have some permanent loads, nothing special, and here's some live loads. And now I want to show you the easy way to design wind loads with our load wizard. And we find this here, and for example here our wind loads, and so we have a flat roof, and now we want to find the base corners. Okay, and also the roof corners. Okay, and now you see all walls are automatically RFEM see automatic the needed walls and roofs. And another nice feature is the definition type with map and parameters. That's the way I switch to the German annex, because yeah, you need this national annex to define or to get or to select selected on the wind load map. Yeah. So let's for example, let's choose the main quarter of Dlubal. It's here in Tiefenbach. Weg 2. Okay, why I'm not connected? One moment. Okay, now we have it. Okay, and yeah, let's say okay, and you see the program transfers informations from these wind load maps, the terrain category, load zones, and all informations for the wind loads. Also, you can generate per direction automatically load cases. Let's do this here with this button. And you see all directions. Okay. And now we have our wind loads fast and correct generated for all directions. And yeah, I find it's a very nice feature. The same for snow loads, but so also a connection with the I say Google Maps view. So with this load maps, the same procedure. And then for buildings, we have very fast the snow and wind loads generated. Okay, that's the points about the quick modeling. Then I will switch back to my PowerPoint presentation to the second point, the story types. After definition of the stories, you have these 4 types. And what are these 4 types exactly? I will tell you now. Or before, independent which type you choose, you get specific results for mass and story by story results. I will show you at the end of my webinar. Yeah, so okay, then let's start with the this first type. This type is when you would modeling a building on your own way. Then you have only this 3D calculation and don't have these 2D analyzers for slab and walls, which are integrated in the rigid and semi-rigid types. So with this type, it's I say it's like you modeling without building model, and the only positive thing is this specific results. Yeah, okay. Then we have the next type, this rigid diaphragm. It's for, I would say, traditional structural analysis types or calculations. So where this 3D effects are not considered. So here the slabs get infinite rigidity and the 3D calculation, and the calculations between walls and slabs are separated, and the results are only a addition of these calculations, I would say. Other in the semi-rigid diaphragm, here the slabs are calculated with their real rigidity and stiffnesses, and they will consider it in the 3D calculation. So it makes yeah, let's make the model more softer, and yeah, consider better the 3D effects. Yeah. Okay, then we have the load transfer only. Um, this types of the slabs, there is no load bearing and only a load transfer. So like this surfaces I show you for the windows, so these surfaces then don't uh, have a load bearing, only transfer the loads to the walls and so on. And yeah, a good example is here in a bar grating. So you see we have these four types, and it is possible to mixing these floor modelings. So in your model, you can, for example, for the upper story, you can define a load transfer, and for the other, you can choose the others too. So mixing is possible, and yeah, you are free to design how you need it. Yeah, when you define the rigid or semi-rigid floor modeling, uh, you have also the options for to select the support modelings for these 2D analyze for the slabs. And yeah, here the slabs are hinged, let's say, from the walls, and yeah, the type of the hinging you can define here, but I will show you in RFEM Direct. Okay, then let's switch back to RFEM 6. So maybe for a better overview, I will close some. That was a beginning. Okay, I've saved another way. Okay, now we have our four types. So let's start with our type load transfer, that I can show you what is happening here. Wait, that's correct. And so we want to static analysis, and yeah, for example, bending moments. And when you see here, we have no moments in the floors. Only forces are in no forces in the slabs. Only forces in the walls. So it here is no wall, no slab activated. So really a simple load transfer, and yeah. So then we can close this too. And now let's compare this way. Moment, and maybe we can minimize this, and again here. So now we have our rigid type, and I choose the third floor, and okay, and we want to have the same overview for our semi-rigid. that I can show you the differences directly. Okay, so wait, okay, one moment. Why it's still activated? Okay, then yeah, let's choose a load case with wind and self-weight for both. Okay, so when we now switch to the static analysis, we have here an additional point, analysis of building stories, and this analysis of building stories are only possible with the type rigid diaphragm or semi-rigid diaphragm. So then maybe let's look at the floors at first. Moment is okay. Okay. Wait. Let's switch to isobands. And here we need also MX. Yeah, you see here between type rigid and semi-rigid are no differences. It's exactly the same calculation. Also, when we switch to deformations, for example, so it's really exactly the same. And the difference is between this Ward's calculation. So when we look at our rigid type, maybe again or X and also an X. Yeah, you can see it here. In the rigid type, the slab is here with their infinity stiffness and don't have an effect of calculation for the walls. So the walls stand alone more and more. And here in the semi-rigid type, the slab have also an effect in the 3D calculation of the walls. So yeah, also for the deformations, you can see it here. So yeah, here we have only 1.8 because the stiff slab, and here this softer slab through the real rigidity of the slab, we have a bigger deformation, and I call it the traditional structural analysis. So calculation with positions in a static, and you can see it. Wait, let's activate the values on surface. Wait, let's again switch to X. Wait, let's make it this way. We see it better. So the walls, let's here these 0.238 and the floor 1.005, and these walls and floors are only a result of walls and floors editing. So when we see it here, so we have here our 1.005 and here our 0.238. So you see it's independent, so or it's not affecting each other. So yeah, that's the rigid type. Then let's switch back to our semi-rigid. Yeah, let's go here maybe. So surface 5.8. Here you see we have different or wait, it's in the global deformations we see a difference. So we have here deformation 3.1 and here 0.3, and here it's yeah, a mix of both. So um, yeah, the results are working together, let's say in this way. And again here to rigid, yeah, with the deformation. Yeah, I think, sorry, it's a better way. So let's see, here we have for the walls 1.8 and for the floors 0.3, and this show only the maximum of one of these, and it's exactly the 1.8. Yeah, okay. That's with this point. Then I will switch back to my PowerPoint presentation. The shear walls and the deep beams. Both objects you must define on manual way, and choose the surface or surface cells, or also you can choose members to define um, these objects, these shear walls and D-beams. And both objects automatically generate a result beam, which integrate or it's an integration of surface forces and integrated to member forces. And you also have the option to generate result sections, and result sections create an intersection line, and on this line yeah, you can see results on this area, let's say. And yeah, important for deep beams to consider nonlinear calculation, or the forces which come um, through this surface type. So when you have uh, yeah, it's according to the ratio of height and length. And when this height to length ratio is smaller than 0.5, so when you have a really long um, uh, beam or a long surface with a low height, then this result beam is perfect for this calculation. But when you have um, a height to length ratio bigger than 0.5, we will, or we say use result section um, to um, have a better result or more realistic result for these effects. We also have a knowledge base article on our website for this, deep beams, um, and there you can read it again, and there is the effects are explained there more in detail. Okay, then let's switch back to our RFEM model. I will work now with the type, this type, and want to show you yeah, how you can define shear walls and deep beams. So I have modeling it before, but so you can create a near shear wall, and yeah, you must assign objects. I have choose surface and cells. Maybe wait, then let's show you the shear wall. Yeah, that's so a wall from the ground floor to the highest floor, and yeah, um, then when you activate um, the design add-ons here in this case, concrete design, then you see here the typical tabs you can find also in every other concrete design objects. Yeah, you can define shear reinforcement, longitudinal reinforcement, and all the other definitions. Yeah, okay. Also, yeah, to the definition of the reinforcement, must say when it is simply wall, so in this form, or I'm not 100% sure, but for example, some other simple geometries, there it also will be possible to define your reinforcement. But when you have an um, I don't know, a complete individual form, um, there it is not possible to create such reinforcement in RFEM6. But we have an option here with this button. You can open our section and RFEM export your individual section to our section. Then you can define there the reinforcement what you want, and send it back direct to RFEM6, and it is actualized here, and then you can calculate it with your own defined reinforcement. Yeah, that's a point I want to say. Okay. Okay, then maybe let's we are in the concrete design, and you also see we have here additional object types, shear walls, deep beams, and also in our concrete design we have here design ratios and reinforcement for shear walls and deep beams. So you can see here, like for other objects, calculations and the results for analyzing. Okay, so but a big point for these shear walls, you guys also have it in the table, but I will show you my next chapter. But here, for example, you see the axial forces which you get per story, and the moments, and yeah, it's very good, and um, for controlling and for seeing which forces are here, and yeah. Okay, then the same procedure for the deep beams. Sorry again. Yeah, the deep beams you also can define like the shear walls is the same, and here I generate result sections because what I tell you before in the PDF presentation, the height to length ratio, you should look on on this, And yeah, I want to show my shear wall. I have create an own object selection for this. And yeah, I have very less loads, so this is only um, construction reinforcement. So normal, you have more on the bottom side and so. But I want to only show you the workflow, how you must work with this, or with this results. Yeah. Okay. So when we look on the reinforcement on our D beams, and no, sorry, we need a surface, of course, because the D beam here is our result beam, but because of the height to length, we must do it over the surface with result sections. Yeah, and you see in this direction, it show the required reinforcement on the bottom side, and where you have this steel tension, what you need. So let's remember it's the one direction in the one direction, and the second direction is for um, the shear reinforcement. So when we look at our result diagrams, let's remove all and go to here 1 1. Then we have this results here. Now we must define a smooth range over the whole length. So we have 3 meter constant, and now we have our result. So we need this 4.31 plus 4.31. So we have an sum of 8.62, which we must put into the bottom side of the D beam, and the other, the shear reinforcement, we look at both directions, top and bottom, and choose here the maximum value. So yeah, here it's every same because we don't have big loads here, but so we must choose this 1.8 for the shear reinforcement. And yeah, that's a workflow we have at the time. Yeah, okay. Yeah, that was about shear walls and deep beams. Let's cancel this visibility, and yeah, let's switch back to the PowerPoint presentation, to the last chapter, the result evaluation. Yeah, when you here click the static analysis, you have this point results by stories, and you have this 5 tabs here: the center of mass and rigidity, story actions, interstory drifts, then forces in deep beams and shear walls. And yeah, maybe it's easier when I show you on the program. So let's switch again to RFEM 6, and let's go to the static analysis and results by stories. So let's start with the first tab, the center of mass and rigidity. So the mass show the mass per story. So you see it's nearly the same here. Only the ground floor have more mass because of our foundation um, plate, and yeah, and so out of this masses, RFEM create or show you the mass center for every story, and we also have the cumulative mass. And this mass, maybe you see here in the top floor, it's exactly the same. Also, the mass of center, and the difference between this normal mass is um, that these masses are added from. So this mass is the third floor plus the fourth floor. So this is yeah. So it's addition. So the mass is growing from top to the bottom side, and um, considered the mass from the previous stories. So and out of this considering, you have another center of mass, and this is the center of cumulative mass. Um, oh, and with this mass, you can work very good in dynamic analysis. Um, yeah, but that's yeah, I don't have enough time to explain it now. But yeah, it's a very nice feature for dynamic and yes. Okay, then to the story actions. Um, the story actions is about, let's say, horizontal loads. You see here the Fx and the Fy. So in global direction, there you see the influence of horizontal loads, which come on the building on the for every story on the top and bottom side, and here also the delta story forces. So yeah, and out of these horizontal loads, there is created also a location of the resultant, and yeah. Okay, then we have the interstory drifts. Um, yeah, it's bad to see here because we have such low loads and real stiff building. But yeah, you can see here the displacement in also in the x and y directions, and can here if you have more loads and a very good view, the influence of every story, and yeah, the deformations per story, and yeah, it's okay. um, and also here about the deep beams and shear walls, you can see the results of the result beams which are created for the deep beams and the shear walls, and yeah, you can see all forces which are there in which story, and it's yeah, good. For example, here the axial forces, you see how it grow every story, and what I showed you before in the graphic menu. Okay, yeah, that's about this results by stories, and that's about my webinar today too. I will thank you that you're looking my webinar, and I hope I can show you some new And if you have questions, you can write us on the info@dlubal.com. And thank you for watching. And I give back to my colleague Andreas.
Thank you, Richard, for your nice presentation. I've got an additional hint for you. Our online courses are on our website. Where are free courses. They take about between 2 and 3 hours. That's the RFEM 6 course for beginners. That's the Eurocode 2 course for the reinforced concrete design, and the Eurocode 3 course for the steel design with RFEM 6. You can scan the QR codes or click on the links at the bottom for more information and for prices. You can stop the course anytime and continue when you have time again. There are several parts, and as I said, you can stop and continue or when you have time. Okay, that should be also all from my side. I thank you for your attention. Thanks to Richard for the presentation. I wish all a nice rest of the day. Bye-bye.